Hello, everyone. This is part 4 of the President's Networks, and we're still talking about the four relationships. And just to recap from previous lecture about this slide here, we said that start-to-start relationship, finish-to-finish relationship could be combined, but one of them has the driving approach, none both of them. In other words, you have to identify which one is the driving relationship to be able to determine your CPM. And also we said the lag and leaks are utilized in the four approaches. This actually takes us to the combination of start-to-start plus the finish-to-finish relationships. If you remember the four relationships we covered in the previous lectures during this chapter, was about how to utilize the four relationships: finish to start, start to start, finish to finish, and finish to start relationships. But just the start to start plus the finish to finish relationship could be combined. And actually, this is very powerful approach to utilize when you work on your CPM. So because of that, we'll probably focus on this from now to the rest of this chapter and understand how can we combine them in a forward pass approach and backward pass approach. Now, typically when you work, let me grab my laser pointer. When you work on this type of relationship, the combination one, things you need to expect that each has different results, but one of them has to be the driving one. We cover that, and typically one of the two sets violates the logic. If they violate the logic, then you have to revise your sequence because they don't make sense. But you have to make sure that the driving activity is identified ahead of time. And of course, this for the backward and for the forward passes, they both are the same. So for example, on the lag here, we have two different scenarios. The first scenario is when you have a start-to-start relationship with a 3 days lag, right? So these 3 days allows you to start the clear and grub and excavation both in the same time, yet they have different type of duration. And as you can see here, the clear and grubs is 10 days, right? While the excavation is 6 days. From Gantt chart, we see this here is unrealistic. Even with the lag, it still doesn't work, right? Because if you have 0 start and then you add 3 days on it, even if you give 9 days worth of length of an activity, it's still 10 is the critical one. So to me, this is unrealistic approach, even if it's a start with a lag of 3 days. The second one is finish to finish. So the finish to finish could be written or drawn as this way or this way, right? We covered this already, but just to recap on it quickly. So then if we have the first activity 10 days duration and the second activity is 6 days duration, as you can see, but then the negative activity, the negative lag is 7 days. This means that this activity can start on day the third day of 10. So imagine if this is 0, right? And let me grab my pen. So let's assume the starting day here is 0, and then the yearly finish is 10. Then 7 days for this activities can start. So it doesn't have to, so you don't have to wait for this activity at day 10 to finish for this activity to start. This activity can start, like if we assume this is the timeline here, 0 to 10, then it can start on the 3rd day here and move forward. The same thing here, but with 1 day duration. So to me, this side, the finish to finish with lags, is more realistic, because I'm giving it 3 days for the excavation to start after the clearing and grubbing. The same goes here. I'm giving 1 day for the excavation to start after the clearing and grubbing has begun. Okay, if that makes sense. More examples on that. We have this scenario, A, B, and C. Again, they all have start-to-start relationship and finish-to-finish relationships. Remember, we're working with the combination relationship, start-to-start and finish-to-finish. So then if they both can start on the same day and we're giving 2 days lag for B to start, then it's safe and it's more realistic. The same goes with C. Yes, they have start-to-start relationship, they can, but we're giving 3 days lag to C to start after B begins. But we also enforcing this condition where B cannot finish until A finishes, and C cannot finish until B finishes. But also to make sure, we gave 1 day extra as a lag for C to complete, just to make sure. If you guys remember from the previous lectures, we said we don't want B and C, the bedding or the sub base and laying the pipe, finish on the same day, because it's unrealistic, and you still need to give at least 1 day to make sure that everything per the specs or the specific specs are done. And the same scenario here, when we have these 2 days are started and with 2 days lag. Now, if you notice, the starting of the early start of B is 7. This is the case of the contiguous activities. So A actually starts and continue until it finishes. And from here, we can see that it finishes at day 7 where B can starts. But we're still giving it a 2 day lags for B to start. So we can implement what's so-called the overlapping activities. And the same goes here. So, and again, for this scenario, we imposing the finish to finish just to make sure that everything is falling in place. And because of this sequence, we have C at 15 days to be done, which is more logical. So now, if we implement the Gantt chart for A and B, we see that A and B are done both in the same day or on the same day. However, we still gave B the leverage to be done after A is finishes, if that makes sense. So to me, this is very logical.